Okay, here we go. Monday, May 4th. This is Mr. Childs, dressed in a dress shirt today and no hat. Getting back to basics here a little bit. This is college prep statistics. And this is the May 4th. If you like Star Wars, you might like May the 4th be with you. I'm a Star Trek man myself. I'm going to clean the board off here behind us because that's for my last class, not for you. So let's review. We've had assignments. They are all online, nice and neat. I can't even believe how neat this Google Classroom thing is. Should have known about this a long time ago. But anyway, the assignments are all there and they're ready for you to do them. You know, I like it when people are all caught up, but I am willing to accept work at any time. So don't feel depressed that you can't make it up because you can. So do that. The only thing I ask is if you could put the date of the particular assignment. It makes it a lot easier. When I have 6 classes coming in, it's kind of hard to keep up with the assignments. So if you could do that, that would be great. Okay, let's look at what we had last week. We had a tree diagram, which I thought was so appropriate for the times. We talked about social distancing and the outcome of whether people end up with the virus, the coronavirus or not. So that was last week. Also, we're in phase 3 here, and I've been told in phase 3 there should only be 1 assignment per week. We were doing kind of 3 little mini ones before. So what I'll do is just kind of introduce the topic I want to talk about next today. And then on Wednesday, we'll do an assignment, and then you can do it on either on Wednesday and Friday. That would be great. Okay, today it deals with the tree. We're going to use the tree diagram again, but in tree diagrams, you can combine that with conditional probability. Okay, tree diagrams and conditional probability. So let's use that old problem last week, the social distancing one. Let's say, I don't remember our numbers we use, but it looks like people are not following the orders very well. So we will say social distancing. That will be our first branch. And let's say, let's say people are being bad. 60% yes, 40% no. Remember, we said that everything has to add up to 100%. So 60 and 40, definitely. Oh, I'm out of the picture here. I know you want to get me in the picture. So 60 and 40, 100%. Then we could look at whether you get the virus or not. And virus, yes, no, yes, no. And let's say we don't really know until everyone gets tested. It's going to be kind of hard to know what percent rate it is, but I think it's pretty low. So we will say if you social distance it, the chance of getting it is 2%. And if you do, the chance of not getting it is 98%. Now down here, know that you've been bad. Let's say it's higher. Let's say it's all the way up to 10% that you could get it and 90% you couldn't. Keeping in mind, each branch has to be 100%. Okay, so from last week, let me get my calculator out here, and we learned by multiplying these two conditions together, we can figure out what 4 different outcomes could be. So 0.6 times 0.02 is 0.012. What does that mean? That means you social distance, but you still got it. So, and I think that's possible. 0.6 times 0.98, 0.588. So almost 60% chance if you social distance that you will not get it. Those who did not social distance, now actually that's a wrong interpretation. What it is out of all people, if you social distance, almost 60% will not get it, not out of just that group, because that's where we're headed today with the conditional probability. 0.4 times 0.1 is 0.04. So you have you do not social distance, you would be 4% of the population that get it. And the other one will be 0.4 times 0.9, 0.36. So the first thing I would do always from last week is to add all these outcomes. Let me get over here a little bit. These outcomes together and see if they equal 100%. 0.012 plus 0.588 plus 0.04 plus 0.36, and it equals 1.0. So we're off to a good start, okay? Now we can do some different things with this than we did last week. I just asked you for the 4 outcomes. But if I said to you, remember the old conditional probability rule, which is the given goes on bottom and the intersection goes on top. So let's say given that give me a moment here. Given that you did not get the virus. All right, let's go with that. Given you did not get the virus, so how many percent did not get the virus? This and this. So given you did not get the virus, which is 0.588 plus 0.36, which is pretty realistic, I think. 0.948. Is that in the picture? Yep, good. And so given that you did not get the virus, what is the probability that you social distanced? So you would come up here and, you social distance. So right here, you do not get the virus. What is the probability that you social distanced? Hold on here. We've run into a problem. Oh, I see. Yes. What is the probability that you social distance? So we added these two, but that is the total, but the percent that social distance is right here. I'm sorry, 0.588. It's a Monday morning here, Not that I don't make errors sometime anyway. So once again, did you get it? Total that you did not get the virus, that these are both no's. What is the probability that you social distance? Here is I social distance and I didn't get the virus. So 0.588 divided by 0.948. About 62%. So your answer would be 62%. Okay? So that's a little warm up. On Wednesday, I'll come up with a new scenario. We'll move on from the virus. And we'll make a tree diagram, and then we'll do some problems, and we'll have you do the problems dealing with conditional probability and tree diagrams. Okay? Well, I hope you had fun this last weekend. The weather was very nice, and hopefully it will continue to be nice. And hopefully soon we'll get our lives back to a more consistent basis. I hope so. I hope that for you, and I hope that for me. See you later. See you on Wednesday.